All right. Slope is a topic that probably gets covered in every high school math class because slope actually ends up being, believe it or not, slope is approximately half of calculus. A little bit more complicated than what we're doing here, but it is still, it's basically something you will talk about in calculus quite a bit. Slope can be represented many different ways. Normally we say m. That's kind of the lazy man's way of doing it, and let's face it, mathematicians are kind of lazy. Okay? Rise over run is sometimes how you've heard it. For some of you, this may be a new one. Okay? That is pretty much always how I look at it, because in calculus, that's how you're going to look at it. Now, I don't know. I know some of you were in Algebra 2. Were you told what that triangle-looking thing was? Were you told what that was? Okay. Okay. It is a Greek letter. It is the Greek letter delta. Okay. All the Greek letters actually stand for something. For example, pi is a Greek letter, and it stands for something, a number. Okay. The ratio of circumference to diameter in a circle, correct? Here, delta means change. So it means change in y over change in x. So as y is changing, x very well might be changing as well. Does it have to change at the same rate? Or can they change at different rates? In other words, can I have a different number on top and bottom? Yes. Can they be the same? Sure. Okay. But they might not be. One might be negative, one might be positive. They might be different. So it's how is y changing as x is changing is really what it is. And this is a formula that a lot of you probably like to use that helps you. But you know what the hardest part about slope is to remember that change in y is on top. Because we most likely, if we're being logical, we're probably going to put x on top because it comes first. Okay? But change in y does go on top, and that's agreed upon, and that will stay the same throughout mathematics, that y is in the numerator. So for those of you that do like to use the formula, you get 2 points then, because that's what you're doing. You're finding out what's kind of the tilt between those 2 points if I connected them. That's what slope is. Okay? Or how would I have to change x and y to get from one point to the other? Okay? So if you're given 2 points, you have to kind of get the notation in there. So that's the first x and the first y. That's just subscript. That's all it means. And this is second, whoa, that's a y, sorry. Second x and second y. Okay. Now, the nice thing is you can kind of jumble these up, but don't say, for example, that this is x1 and then that's y2. That's when you're going to get into trouble. Okay, if it's the first point, leave it the first point. If it's the second point, leave it the second point, however you're going to view it. If I follow this formula then, it says y2, which is negative 8, minus, that's a really bad 8, but you heard me say what it was, minus y1, which is 4, divided by x2, which is 6, minus x1, which is 3. What does order of operations tell me to do first here? Yes? Yeah, how come it tells me to do the numerator first and the denominator? Because really, what is this division bar? It's actually a grouping symbol. It's not one of them we think of. It's like parentheses or brackets. Do everything on top first, everything on the bottom next, and then try and put them together. So I basically owe somebody 8, and I owe them 4 more, so I owe them 12, right? On the bottom, I have 6, and I have to give away 3, right? And so the end result is 3. Okay? Now, really, so in other words, to get from that point to that point, the y value had to go down 12, right? Because change in y is on top. And the x value had to change a positive 3 overall, correct? But again, sometimes we like to talk about it in simplest terms. Okay? But you agree, that's actually how you would get from one of those terms to the other, or one of those points to the other. You would go basically down 12 and write 3. That's what it's saying. Change your y value by down 12 and write 3. But we like to simplify things a lot of times. And so let's do that over here. What can come out of both of those numbers? Yes, just shout it out. The 3. All right, so it's negative 4 then over 1. Do you believe that is an acceptable way of writing slope? Negative 4 over 1, is that okay? Yeah. So wait a minute, how is that possible? Well, that means you would just go down 4 over 1 3 times, because we just took a 3 out, right? And then would I get from one point to the other if I did it 3 times? Sure. Okay. Is it okay to write the slope as just negative 4 in this case? Sure. Is it okay to write the slope as is that equivalent to the other number? Yeah, it actually is. That's still negative 4. 4 divided by negative 1 is negative 4, correct? It is equivalent. Okay, it would work. Okay. Is it okay to do this? Is that equivalent? No, that is not the same, is it? Because negative divided by negative is positive. So is that the same slope as what we had before? That's a big old no. Okay. Is it okay to just put kind of the -4 kind of in the middle like that? That's okay. And then you get to decide if you want to put it in the numerator or the denominator, correct? It's your choice. So there's lots of ways of writing that. So in other words, the slope here is -4 is how we would describe it. Because as the y changes going down 4, the x would change going over 1. Okay? It's the same ratio as the other one. Any questions? Okay. So some of us like to probably look more graphically. I like to give you lots of options. I like to give you visual and algebraic and let you decide which way works for you. So let's determine the slope between -2, 3. Well, let's find out where that thing is. -2 and 3 is right there. Did I give you a graph or no? No? I'll just throw one off to the side if you want to do it that way. And then -4, 4. So 1, 2, 3, 4. 1, 2, 3, 4. Did I graph them properly, the 2 points for letter A? Do you agree with that? Okay. So let's just do this one. I could go like this to like that, correct? That's how I could get there. So basically, we could do this lots of ways, but if I started at this point, I really went left 2, correct? So that would be -2. And then I went from this point, I went up 1. Do you agree with that? So based on this picture, we'll go do it algebraically. But based on that picture, what should be the slope? It's change in y over change in x. What was the change in y? Which two values, the 1 or the -2? Was the change in y value, the up or down, was 1, and the change in x was -2. So we should get 1 over -2, right? Change in y on top, change in x on the bottom. You with me on that? Well, let's find out if we get that. x1, y1, x2, y2. It says take y2, which is 4, minus y1, which is 3, over x2, which is -4, minus a -2. Are you with me so far? So on the top, we have 4 minus 3, which is 1, over -4 minus a negative. So really, that means add the opposite, right? That's how you were taught that. Okay. So -2. Did we come up with the same answer, doing it visually and algebraically? And should that happen? Yeah, that's really what you're doing. You're just finding what those two things are, right? Because you notice you're just finding that absolute difference again. That's all you're doing, finding that distance. It's the same thing we did a chapter ago, that absolute. Okay. So in this case, is it okay to give that answer? Is that equivalent to the fraction that I have? Yes, it's the same thing. But how does that work? Well, that just meant I went the other way. I went from this one and went to that one. So I went down 1 and to the right 2. You see how it still ends up being the same thing? Depends on which way you get there, right? So why don't you go ahead and do B and C right now. For those of you that are listening to the recording, actually pause the recording and don't just wait for the answers to pop up. All right, let's see what we got here. So we've got 7, 5. Where's that over here? So 7, 5. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. And -3, 5. Ooh, we better erase some of these other ones, huh? -3, -1, 2, 3, 1, 2, 3, 4, 5. Agreed? So in other words, I got to figure out how to get from there to there, or vice versa, go back the other way, right? How do I get from one to the other? Agreed? So visually, what is the change in y value? There isn't one, right? The change in y value is nothing. It doesn't go up or down at all. So the change in y, I don't even know how to draw that, is 0, right? Change in x, well, again, you can do that absolute difference. But basically, we know from here to here is how much is 3, and then it's another, whoa, I went too far there, but another 7. So how much is that? 10. So change in y is 0. Change in x is 10. 0 divided by 10, then, correct, is your slope. Okay? 0 divided by 10. So if I have nothing and I want to divide it up to 10 people, can you do that? Sure. Everybody gets what? Nothing. I can do that. If I have no money and I divide it up to 10 of you, you each get nothing. That can be done. Okay? So it's basically telling you how much each of you would get, so the slope actually is 0. Okay? If you do it algebraically, it'd be 5 minus 5, because it's y2 minus y1, and then x2 is -3 minus 7. So now this is weird. I get 0 over -10. Is that equivalent to 0 over 10? Yeah, they're both what? 0. It doesn't matter, right? So that does work out. So this one does have a slope of 0. Now it just looks like a donut. Okay? All right? Yes? Okay, the question is on a test, could we write it as no slope instead of 0? Um, I would actually prefer that you put that the slope is 0. That's just a personal preference because too many people get no slope and undefined confused. So tell me here that the slope is 0. Okay? And the last one. What do we got? 5, 7. And so 5, 7. So here's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And 5, negative 3. How about change in y? Well, the change in y is 10, right? Change in x is nothing. So if I put them over, ooh, that's a problem. Okay? Is it okay if I don't do that one algebraically, or would you like to see it algebraically? We're good? So we know that if we did it, it's either 10 or negative 10 over 0, correct? So now I have $10 and I would like to divide it up to 0 people. Yeah, that's a huge problem. You need to know that dividing by 0 is the one thing not defined in mathematics is dividing by 0. Okay? And it truly, the further you go on in math, the more that becomes pronounced, that you can't do that. Okay? So seeing we can't do it, we start looking for places where that happens. Seeing it's a problem. It's the one thing not defined. So this one here, you truly would say undefined because it is not defined. There's no definition for dividing by 0. Okay? In other words, it's how many groups of 0 can I put into 10? That doesn't even make sense. All right? Now, people remember that lots of different ways. These two are very special, B and C. Very special cases, so know them very, very well. Okay, you may just want to put it to memorizing it. All right. Let's graph a line that passes through 1, 3 with a slope of negative 2/3. So probably the first thing is to find 1, 3. Well, let's find 1, 3. Where is it? 1, 3. 1, 3 is right about there. Agreed? With me on that? Now, the slope has to be negative 2, 3, so that means I just do whatever I want? No, what does that really mean? That means as I look at it as this way. As x changes a positive 3, in that same amount of time, y has to change how much? Negative 2, correct? That's what it really means. So as x changes a positive 3, so let's change x a positive 3. Do you agree that's where that would be? 1, 2, 3, right? In the same amount of time, y changes down 2. Agreed? Does that keep happening? Yes, that is that rate of change. As x changes 3, y changes negative 2, so you could do it again. Okay? Now, here's the real tricky part. Can I switch this around? And you told me that is equivalent, correct? So should that still work? That's still the rate at which things are changing. But wait a minute. Now x is changing a negative 3, which means not right 3, but left 3. And in that same amount of time, y is now supposed to change a positive 2. Okay? So all of those points seem to be agreeing with each other. They do because if I take all of those points I just made, they form a line. Okay? You notice I had stuff in there already for you. Ooh, the line's green though. That was interesting. Okay? So right here, this is a change of positive 3 if I'm going this way, right? And negative 2. Is that the slope of negative 2/3? Yes. Okay. Now if I go this way, now it's a change. Well, it's the same thing. Change a negative 2 as x changes a positive 3. Okay. That's what slope is. So it's a rate of change. As one is changing, what's the other one doing in the same amount of time? Okay. You with me on that? All right. So certain things, I believe you have this on yours, right? And it says it's a positive slope. So how could we describe a positive slope? What is it doing as I move from left to right? What is it doing? It's rising. That's a very good word. So this one is rising. So as it goes from left to right, is everybody clear on that? As x goes from this way to that way, what is happening to this graph? It is rising as it goes to the right. Agreed? So that you're telling me is a positive slope. I agree. Uh-oh. It's going to be that way, huh? Fine. All right. Is that a positive slope? Is it still rising? So in other words, as x is changing in a positive direction, the y is also changing in a positive direction. Agreed? So that is definitely a positive slope. Or you could say as y, if you're going the other way, as y is changing in a negative direction, the x is changing in a negative direction. Negative over negative is positive. Amazing. How about that one? That one? No. Okay. Because now as x is changing in a positive direction, y is actually changing in a negative direction, or vice versa. How about that one? That one? No. Okay. That is not. So to change it back to a positive, it looks something like that, correct? How about a negative? How would we describe negative? What is it doing as you go from left to right? It is falling. Very good. Okay, again, I could move this around, but you get the idea, correct? All right. This next one you have, I believe, is horizontal, would be a good, uh-oh. All right, well, you know what? I'm going to cheat. Horizontal, correct? That has a slope of 0. Very good. So is that a slope of 0? What would you describe that as? What? Positive. Slope of 0? Slope of 0? No, it's what? Negative. All right. There you go. I'm guessing I'm going to have to cheat again, though. Oh, sure, that one works. All right. So that one, what's a good adjective for that? Vertical. Very good. And what's the slope there? Undefined. All right. So now, I know I've given lots of different memory devices in the past to remember these two, but remember, I just told you on the last page that these are the two special ones, correct? Okay. So these are the ones you need to know. One way that I have taught it in the past is this is a horizontal line, so it looks a lot like the horizon, correct? What comes up over the horizon? The sun, which looks like a 0. Okay. So up over the horizon, right, is the 0. And then you just know that that one's undefined then, because you know there's one or the other. The other one I've heard that I believe I have borrowed from another teacher is that if you were skiing, this would be more like cross-country skiing, correct? And that person thought that the degree of difficulty for cross-country skiing was 0. I don't know if any of you have ever done cross-country skiing, but the degree of difficulty is not 0. It's really hard work, okay? But that's what they said. And then over here, they said if you were trying to ski on a slope that looked like that, they basically said that you're not skiing, you're just falling. All right? So that would be undefined degree of difficulty, correct? Because you're not even skiing anymore. That's just flat out falling. All right? So here, cross-country skiing, apparently degree of difficulty 0. Here, you're not even skiing anymore, you're just falling. Okay? So those are two huge ones to know. Parallel lines. I believe that one of you actually gave me kind of the definition that deals with slope here, but we know flat out that parallel lines are lines in the same plane that will never intersect. You already have that definition in your notes, correct? Okay? So it must be really important if I'm having you write it again. Okay? But now we also know, at least I think it's written there. Maybe not. Apparently not. That we have a symbol for that, right? What's the symbol for parallel again? Yeah, it kind of looks like an 11, right? So like if M is parallel to L, right? Train tracks, yep, there you go. One thing you need to know, I know it's in there somewhere though, because I can see this one. There it is. The slopes will be the same for those two lines. How x changes as y changes, that's if the lines are parallel. They will have the exact same slope. Yes? Oh, yeah, so add in the stuff. I already gave you the definitions apparently. So if I told you line M had a slope of 2/3 and L was parallel to it, what must L's slope be? 2/3. Very good. There's no way around that. They have to be. Perpendicular lines. Do you have that definition down already? Wow, you're so lucky. All right, lines that intersect at a right angle. Okay. And in this one, the slopes will be opposite reciprocals of each other. Okay. So let's go back to this. Let's say we have lines M and L again. And then let's face it, if mathematicians are not going to write out the word parallel, there is no way we're writing out perpendicular. That's way too long. Close, upside down T, but that could look like a plus sign, depending on what T you use. Upside down capital T, there you go. There's your symbol for perpendicular. Okay? So if I told you that, and let's stick with this same 2/3 that we had up here. If I told you M had a slope of 2/3, would L also have a slope of 2/3 if they were perpendicular? No. There's two words there, opposite and reciprocal. Yes? Sure. I've been told that the answer is -3/2. So what this person did is they took the fraction and flipped it over. What part of opposite reciprocal is that? What part of flipping the fraction over? What's that called? That's the reciprocal. Opposite means change the sign. Now something you may never heard before, one way you can check that is if you multiply the two together. Wow, I don't know why one fraction went one way and one went the other way. If you multiply the two fractions together and they are actually perpendicular, you will get -1 every time. If they are actually perpendicular. Okay? So for example, if I told you one of them was 1/2 and the other one had a slope of -3/2, you should be able to tell that those are not perpendicular really quickly, correct? Because that does not multiply to be -1. Okay? Because it would be 1/2 and what? What would be the other answer, actually? -2/1 would be perpendicular, right? Those two. Right. Any questions? And just a critical, apparently I don't, do you have the critical thinking one on here? Okay. It says, how could I determine if 4 points are the vertices of a square? There's more than one answer. What are some of the things I could do? So let's say I just gave you a point here, I gave you a point there, and I gave you a point there, and I gave you a point there, and I wanted to know, are they a square? And I wanted to know for sure. Realize that you shouldn't use the, it looks like it, defense. Okay? What are some things that I should investigate? Yes? Okay, yeah, if we have, for example, A, B, C, D, is AD even parallel to BC? Because they should be, right? And then is AB parallel to DC? Is that a good start? Sure, that's a very good start. Are they parallel? Is there anything else I should probably investigate? Because that tells me then that I have a parallelogram, correct? Is there something else I should maybe investigate to be sure? Yes. Yeah, is DC perpendicular to AB? And again, we could look at the slopes there as well, because we already did slopes, right, to find parallel. So we could do slopes, they better be opposite reciprocals all the way around, right? So that would be a good thing to look. So now we are guaranteed to have a rectangle, right? So we need to make sure that we have a square. So it's one more thing we should probably investigate. What about a distance? Yeah, is this distance the same as that one? And is basically all 4 of them have to be the same, correct? So we would have to do quite a bit to be sure that we have a square, correct? Is saying it looks like it much easier? Yes, it is. But are you sure? No. Okay. So those are good strategies. We said slopes, we can check parallel and perpendicular, and then also distance formula to find out if the sides are all of the same length. Okay. Any questions on that? So that would be some of the strategies you could use.